Okay, I received several emails about different questions from homework problems, so I just wanted to make this video going through all of those homework problems. So I just have them all written down. Let's see. Starting in section 1.5, we have 12, 62, and 72. And then in 1.6, 48, 72, and 76. Okay, so 1.5, number 12. Use the point-slope formula to write an equation of a line having the given conditions. Write the answer in slope-intercept form. So I have passes through -4, 8 and -7, -3. Yeah, good. Okay, and ultimately, as I've said in the videos, I don't necessarily care what form you put your answer in. You need to be able to write the equation of a line. There's standard form, slope-intercept form, and point-slope form. If there's one you prefer, go, and you are good solving it algebraically, go with that. But be aware that for problems in your book and in ALEKS, occasionally you will be told you must put your answer in a certain form, so you do need to know all of them. But this one says use point-slope form. Point-slope is y minus y sub 1 equals m times x minus x sub 1. In order to write that, I need a point, x sub 1, y sub 1, and a slope m. For your point, you can pick either point, it doesn't matter. I'll just pick the first one. So I get y minus 8 equals m, x minus -4 becomes x plus 4. Now all I need is the slope. Slope, we know, m, is change in y over change in x. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Which for us is -3 minus 8 over -7, -7 minus -4. -3 minus 8 is -11. -7 minus -4 is -7 plus 4, which is -3. Two negatives cancel, and I get 11 over 3. Y minus 8 equals 11 over 3 times x plus 4. Now, that is the equation of a line, but you're told to put it in slope-intercept. If you want to put it in slope-intercept, just solve for y. Distribute in to get rid of the parentheses. Y minus 8 equals 11 thirds x plus 44 thirds. Then add the 8. Y equals 11 thirds x plus 8. In terms of 3, 8 is 24 over 3 plus 44 over 3. 24 and 44 is, I think, 68 over 3. And there's my equation. And again, in general, this is the equation of a line, that's the equation of the line, they're the same line. Personally, I don't care which one you use. You can use this one. Just be aware, sometimes the book wants you to write it in a certain form. Okay, number 62. Caroline adopted a puppy named Dodger from an animal shelter in Chicago. She recorded Dodger's weight during the first 2 months. The data in the graph show Dodger's weight X days after adoption. Use the points 0, 11, and 40, 22 to write a linear model for these data. So, we are told use the points 0, 11, and 40, 22. Again, to get my slope, my equation is going to be y equals mx plus b. I'll use slope-intercept here as opposed to point-slope. Again, it doesn't matter. Slope, change in y over change in x. 22 minus 11 is 11 over 40 minus 0, which is 40. And there's my slope. So I get y equals 11 over 40x plus b. Now I just need to get b. In this case, I'm given the intercept when x is 0, y is 11. If you don't see that immediately, how do I get b algebraically? I plug in an x and a y that are related. Use that one. So I get 11 equals 11 over 40 times x, which is 0, plus b. That's just 0. I get b equals 11, which means my equation becomes y equals 11 over 40x plus 11. And there we go. And again, you could have just as easily used point slope like we did on the last one. Here I just used slope intercept. There's different algebraic ways to solve these. Interpret the meaning of the slope in context. This is a standard type question. You want to be able to interpret your slopes in context. You're going to do it on your exam, on homework, on labs. But as long as you know the definition, you're good. The slope is change in y over change in x. Now on any given problem, just figure out where y and x are. For this, y is, I think it's weight, correct? Y is weight, x is days after adoption. So it's change in weight over change in days. Now in context, what does that mean? My slope is 11 over 40. So it means every day the dog, I don't know its name off the top of my head, the dog's weight increases by 11 over 40 pounds. The weight changes by this much each day. I would point out, you could also say something like, the weight increases by 11 pounds every 40 days. That tends to occasionally lead to confusion from a student perspective. So I generally always just call this the change and just make x 1. That's the weight change every day. Again, you can say it either ways, they're mathematically the same. As long as you understand, slope is change in y over change in x, y is weight, x is days, done. Interpret the meaning of the y-intercept in context. The y-intercept is the value you get when x equals 0, which is right there. And I think I had a few other questions. I don't know if it's on this question or another one. How do you find the y-intercept? It's actually straightforward. If you have an equation here, I'll write it in standard form. 3x plus 6y equals 12. If you wanted to find the y-intercept for this, to get the y-intercept, you make x 0. Then you get 6y equals 12, so y equals 2. And your intercept is 0, 2. To get the x-intercept, you do the same thing. You make y 0. If y is 0, I get 3x equals 12, x equals 4. And I get the point 4, 0. So there isn't really a formula to find the intercepts. To get the x-intercept, make y 0. To get the y-intercept, make x 0. And then you get these points. But now, for this problem, the y-intercept is the value when x is 0, which I'm actually given right here, 0, 11. In the context of the problem, again, x is days, y is pounds, weight. So what does 0, 11 mean? It means when I've had the dog for 0 days, which means when I get it, it weighs 11 pounds. Done. Okay, the last few parts of this are just plugging in x and y values into your equation and getting a value. So I'll skip those. 72. This is still recording, right? Yep, good. 72. The graph in exercise 62 shows the weight of Dodger, a puppy recently adopted from an animal shelter. The data in the table gives Dodger's weight y, x days after adoption. Use the data in the table to find the least squares regression line, round the slope to 2 decimal places, and the y-intercept to 1 decimal place. Use a graphing utility to graph the regression line in the observed data. Okay, for this one, I'm going to kind of skip over this. Bear with me 1 second. I'm going to see what the actual question was. Right here. Okay, good. There are different ways to go here. One way to do it is to go into Desmos. I can't pull Desmos up here, obviously, which is why I'm kind of skipping this one. Go into Desmos, and it can create a regression line for you. You just list all the points out, which is the data in that table, and it can calculate a regression line and graph it for you. So you can do it that way. The alternative, use a graphing calculator. They're not allowed for this class for exams, but you can use them here. Throw it into a graphing calculator. It can create a regression line that way. Or throw it into any online program. Just Google calculate regression line, and there'll be a little table you can fill in your X and Y values, get the regression line, and be good to go. Again, this one, because it's homework, I can let you do things that you're not necessarily going to do on an exam. On an exam, you will not be calculating regression lines because you're not going to have access to any of that stuff. But here, if you have trouble finding a regression line, either through Desmos, a graphing calculator, or an online regression line calculator, literally just Google calculate regression line. You'll get a million websites that'll do it for you. If you have trouble doing that, let me know, and I'll do it like with a video on my computer and go through it that way. Okay, so now we're good with all this. Now we jump to 1.6. So, 1.6, number 48. For exercises 47 through 50, use the graphs of y equals f of x and y equals g of x to graph the given function. So for 48, y equals g of negative x, which means you're supposed to use the graph given, y equals g of x. I'm not going to plot incredibly intricate, but essentially, it's a V that looks like that. Yep, that's 47 to 50. Now all we're doing is going through our transformation. If this is the graph of g of x, what is the graph of g of negative x? We said as far as transformations go, when you plug in a negative, you can either do negative g of x or g of negative x. If you put the negative on the outside, it reflects you across the x-axis. It flips it upside down. If you put the negative on the inside, it reflects it across the y-axis, which means for this, my new graph will take this graph and reflect it across the y-axis. And it'll look like that. And that's it. Nice and straightforward. 72. For exercises 63 through 78, use transformations to graph the functions. 72 and 76. Okay, these will require room. So let me sell this. So for 72, we have g of x equals the square root of minus x minus 4. The first thing to do algebraically, since there's a negative right here, is to factor that negative out on the inside, and you get negative x plus 4, to write it like that, to put it in the proper form to graph it. But now, just do my transformations out. And we have established there's different ways to do this. You can do these step by step, or you can recognize the transformations and do them all in one shot. Since in the other videos I kind of graphed them out step by step, here we'll kind of shortcut it a little. Only a little. I need a starting graph. Clearly my starting graph is the square root of x, which looks like that. Now I build from there. And we'll use different colors. This is not the square root of x. It's the square root of x plus 4. Don't worry about the negative yet. We're building it. What's the square root of x plus 4? If I add 4 on the inside, that shifts me 4 to the left, which means my graph will look like this. But I don't have the square root of x plus 4. I need a third color. That one was dying. Hopefully this red one will work reasonably well. There we go. The square root of negative x plus 4. What does a negative on the inside of my function do? We just said it on the last problem. Negative on the inside reflects across the x-axis. So, I'm sorry, the y-axis, the vertical one. So if I have this, take this graph and flip it, which means it'll actually look like that. But this will not work for this one. Why? Bear with me 1 second. The one trick here, I can't do all my colors at once. Okay. The one trick to see here, and I just erased that, but ultimately, you can actually check these graphs yourself to see if you did all your transformations correct, which is actually what I'm doing as I did this. If I just do that reflection right there, well then, I take this, I reflect it, and my graph looks like that. But the problem is, well, if I plug in 0, here I should get some value. I don't know what it actually is. But if I plug in 0, I should get a number. But if I stick in 0 up here, well, I get negative 0 minus 4, which is negative 4. Then I get the square root of negative 4, which doesn't actually work. So what's going on here? Well, there's actually a trick. And here, if you think about it, and this is why I have to keep erasing. Where is this graph 0? Well, it's 0 where this thing cancels out that thing when x is equal to negative 4. Right here. And now, I actually reflect it that way. And my graph looks like that. So I don't actually reflect the whole wave. Essentially, all I do is I change the direction. And now, if you look at it, if I plug in 0, well, I get something that doesn't work, which makes sense because the graph is only here. If I plug in, I'll get rid of these now so they don't lead to confusion. My actual graph looks like that. If I plug in negative 1, minus negative 1 becomes positive 1. 1 minus 4 is negative 3, which doesn't have a real square root, which makes sense. It's not graphed. But once I plug in numbers over here, we'll say negative 10. Minus negative 10 becomes positive 10. 10 minus 4 is 6. The square root of 6 exists, which is what the graph is telling me. So just be aware as you do your transformations. When you get done, if you're confused, check a few points. Plug in and say, does my graph make sense? Good. One more. Uh, 76. Negative 1/3. X plus 2 squared plus 3. So I have that, and again, here we have to build our graph. We start with my basic function, which will be x squared. Here I'll do this the other way, kind of going back and forth. So first I have an x squared, which will just be a regular parabola. But I don't have x squared. I have x plus 2 squared. What does adding 2 do? Adding 2 shifts me 2 to the left. And my graph looks like that. But I don't have x plus 2 squared. I have 1/3 x plus 2 squared. What does multiplying by a 1/3 do? That's a vertical stretch or compression. Since 1/3 is less than 1, it's a compression. It flattens it out, which in this case means my parabola gets wider. So we'll just do this. And again, I do stress as we do this, you can do your graph this way, you can do your graph the other way. Ultimately, I need to know what your final graph is, and I need to be able to see how you got it, which is why I'm kind of doing these different ways, so we can see all the different ways out. Okay, but I don't have 1/3 x plus 2 squared. I have negative 1/3 x plus 2 squared. So, what does a negative on the outside do? It reflects across the x-axis. Make it wider like it was. So we have something like that. But lastly, I don't have that. I have negative 1/3 x plus 2 squared plus 3. What does adding 3 do on the outside? It shifts me up 3, which means my graph is up here. And it looks something like that. And there we go. So again, you can do these graphs the way we did the other one, where you kind of just quickly sketch each transformation to get to the final graph, or you can do them step by step like this. As long as you understand what each transformation is, you'll be good to go. I would point out, no matter how you choose to do it, on any problem where I have you graphing these things, you're going to have to list out what the transformations are. Because I'm aware that you're doing it online, and in theory, even if I tell you not to use a graphing calculator or Desmos, you still could, you're going to have to list out what every single transformation is. Again, this shifts left, this vertically compresses it, this reflects it, this shifts it vertically up. That's what I mean. Even if you write them in words, you're going to have to show me and prove to me that you know what all the transformations are, and that you didn't just throw it into Desmos. If there are any other questions from the homework, I think we went over all of them, yep. Okay, if there are other questions from homework problems, feel free to let me know, and again, I'll just keep making these videos, going through any questions you have to help you get ready for your exam.